Hello there. Let's talk in this lesson about angles that are half the measure of an arc. So we're looking here in this first circle. I have kind of lightly drawn the central angle. You are familiar with the central angle. And that central angle is going to be the same measure of this arc out here that intercepts it. So this arc out here, this arc out here that intercepts that central angle will be the same exact measure as that central angle in there. However, we have not talked about this other angle back here. Let's name this angle back here. We have talked about the fact that it's named the inscribed angle, and I may have briefly mentioned in an earlier video that the inscribed angle there is going to be, the inscribed angle will be equal to half of the intercepted arc. So if you can imagine, like, if you had, let's say you're looking at a bird's eye view of this and this was some sort of slingshot, if you have it pulled back this far, the angle is one length, and that, remember, that central angle right here is going to be congruent to the measure of the arc there. But then if you pull back a little bit further back here, that this angle back here, which is the inscribed angle, it in fact is half of the intercepted arc that's out there. Similarly, if you have this situation over here where you have a chord, I'll go back and write this down, the fact that this is a chord, and a tangent on the outside. If you have a chord and a tangent, it also forms an angle, for which this angle that is formed right there, that angle, will be half the measure of the arc in yellow. So I'm going to go back and restate this kind of on the side as I did before, that the measure MEAS dot of the angle, that's my angle symbol, will equal half of the arc, and that arc does not have a name. You really don't call it an intercepted arc, but it's half of that arc that is out here. Okay, so let's go ahead and use these types of relationships in 3 examples. In every case, they're going to ask you to find the missing variable, and we can do that. So let's start with our first circle. On first circle, number 1 will be like this, and there will be 3 chords inside. And the information on here is that this is X, this is Y, and this is Z. This piece up here is 90 degrees, that is 170 degrees. And they want us to find X, Y, and Z. And we can do that. X, Y, and Z are all inscribed angles to some arc. Let's look at X. X is inscribed to this arc out here that is 90. So if this is 90, then X must be half of that. So X is 90 cut in half, which is 45. We found one letter. Now let's go to a different. Let's go ahead to, I'm going to go ahead and do Z because we have the intercepted arc out there, and then this is Z, so Z is going to end up being half of that. So 170 over 2, which gives you 85 for this one. Now finally, Y. We can do a couple of things. We can figure out what this missing piece is over here, or if we were to subtract, say we did 360 minus 170 minus 90, we would find out that this was equal to 100. So if this is 100, then this piece here for Y must be half of that. So 100 over 2, which is 50. I can further check myself because 45 plus 85 plus 50, they all add to equal 180, and that is the sum of the angles in that triangle. So I could have just taken the first 2 values here, 45 plus 85, and subtracted it and gotten 50 for that other piece. All right, very good. So just in that way, there are multiple ways you can approach this. You can approach these types of problems by viewing the angles on the inside as a triangle, as you'll see in future examples, or you can work from the arcs on the outside. So there's more than one way to do these. On account of time, I'm just going to quickly approach these problems from one method, the method that I personally find to be the easiest to follow. But if you go another way that you can prove is mathematically correct, that's okay too, as long as we have the same end result there. Let's go ahead to our second example. Oops. Our second example here is a circle that has 3 chords in it again. So it has this chord, and this chord like that. What they tell you is that this one is 62 degrees. This angle over here is 28 degrees. These are inscribed angles, and they tell you that this is x degrees out here. Again, we're finding x, and so now let's go about the process of actually finding x. What I'm going to do is look at this as a triangle and say, okay, well, 180 minus 62 minus 28. Subtract all those from it, and I get 90 degrees. Oh, this was a right triangle. This is 90 degrees. Well, if this is 90, then the inscribed angle is half of this arc, which means that this has to be twice as much, so x would equal 180 degrees. So this is actually a semicircle, making this hypotenuse a diameter in this particular problem. Okay, and you could have checked that again by checking what this arc will be over here based off of the 62, and then this other arc off of the 28, and then you'll find that those add to be 180, leaving you with 180 for the rest of the semicircle, or the rest of the circle there. Let's go finally to our third example. Our third example will be with the second type of relationship that I showed you from the beginning, where you have a chord and a tangent, but we're doing these type of problems together because the relationship is going to end up being the same. I want to know what this, I want to know what x is right here. I want to know what that x is, and I know that this is 220 degrees. So again, there's a couple methods for doing this, but I'm going to do what seems most direct for me. This part of the arc is 220, so although they didn't draw this in the picture, or they didn't give this to me exactly how it's given to me from a book that I pulled it from, I know that all of this is 220 degrees. So then to get the rest of this arc over here, that I don't know, I could do 360 minus that 220, which would equal 140. So this arc over here is 140 degrees, and then in order to get x, I know that x must equal half of that, so I'll take 140, I'll divide it in half, and I'll get 70 degrees. And that checks because with this 220, again, 220, then this likewise must be half of this arc, which is 110. And we know that 110 and 70 that we just found to be the case in here, that checks because it's a linear pair. So 110 here and 70 here adds to equal 180, and so it checks. That would be the other method of handling it. All right, I'll see you in another video.